We like to think of Earth as steady, dependable, and familiar. It's the ground beneath our feet, the sky above our heads, the oceans that cradle our coasts. But the truth is far stranger and far more unsettling. Our planet is not a quiet rock floating peacefully through space. It's a restless, unpredictable force hiding secrets so bizarre and dangerous they could change everything we believe about life itself. Deep beneath our cities, entire oceans may be trapped in stone, larger than anything we see on the surface. The very core of the planet, once thought to spin steadily forever, might actually be slowing down, even reversing, with consequences scientists are only beginning to guess at. And far above, the magnetic field we rely on to shield us from deadly solar radiation is shifting faster than ever recorded, as if warning us that balance never lasts. For centuries, Earth has been seen as home, a stable foundation for civilization. Yet every discovery reveals a darker reality. This world remembers its past catastrophes, and it has no hesitation in repeating them. Ice ages that froze continents solid, firestorms from space that wiped out the most powerful creatures ever to walk the land. Sudden shifts in climate that turned lush regions into deserts almost overnight. Earth is not just a planet, it's a survivor, and survival for Earth has always come at a price. Mass extinctions, collapses, and chaos that reshaped life again and again. And perhaps the most chilling part is this: we are not immune. The signs are here, hidden in rocks, ice, and even the faint vibrations that ripple through the ground. The Earth is whispering warnings to us, just as it has for billions of years. But the question is, are we listening? To understand Earth's story, we have to go back to a time before there was ground to stand on, before there were oceans, forests, or skies. The origins of our planet are not calm or simple. They are violent, chaotic, and almost unbelievable. Imagine a young solar system, not the orderly space we picture today, with planets moving neatly around the sun, but a cosmic battlefield. Clouds of gas and dust clumped together under gravity, colliding with each other at unimaginable speeds. Planets didn't form peacefully. They were born out of destruction, with worlds smashing into one another, breaking apart, and reforming. Earth itself is the child of one of the greatest catastrophes in cosmic history, and if events had played out only slightly differently, our planet as we know it would not exist. The leading theory of Earth's birth suggests that about 4.5 billion years ago, our young planet collided with a Mars-sized object we now call Theia. The impact was so colossal that it melted much of Earth's surface, ejecting vast amounts of molten rock into orbit. Those fragments eventually coalesced into the Moon. In other words, the Moon is not just a companion in the sky, it is a piece of Earth's shattered body, the scar of a collision so violent that it nearly ended our world before it began. Some scientists even suggest that without this catastrophic event, Earth might never have stabilized enough to support life. The Moon's gravitational pull now steadies our orbit and tilt, keeping seasons predictable and preventing chaotic climate swings. What began as destruction became the foundation of balance. But that balance came at the cost of unimaginable violence. For millions of years after this collision, Earth was not the green and blue sanctuary we know. It was a hellscape, a sphere of molten rock and boiling magma oceans. The surface seethed at temperatures high enough to melt metal. Asteroids and comets rained down constantly, smashing into the surface with enough energy to vaporize oceans before they could even form. The sky would have glowed with fire, filled with dust and gas, a place unrecognizable as the home we know today. Yet in this chaos, something remarkable was happening. Water, delivered by comets and stored in minerals, began to accumulate. As the planet slowly cooled, steam condensed into liquid, and the first oceans filled the basins carved by impact. Earth's violent beginnings laid the groundwork for the very element that would one day cradle life. But even this early stability was fragile. The young sun was dimmer than it is today, producing only about 70% of its current heat. By all logic, Earth's water should have frozen into ice, leaving the planet barren and lifeless. Yet somehow, Earth stayed warm enough for liquid water to remain. Scientists call this the faint young sun paradox, and it remains one of the great mysteries of planetary science. Was it volcanic gases trapping heat like a natural greenhouse effect? Was it methane produced by the earliest microbes? Or was there some other unknown factor keeping Earth warm against all odds? Whatever the reason, the survival of liquid water in Earth's earliest days is one of the strangest and most important twists in its origin story. As the surface cooled and oceans formed, continents slowly began to emerge. But these early continents did not look like the land we know today. They were unstable, smaller, constantly breaking apart and reforming under the relentless churn of the planet's interior. The Earth's crust was thin and fragile, easily shattered by tectonic movements and volcanic eruptions. Entire land masses may have formed and disappeared before any trace of them could be preserved. The continents we stand on today are built on the ruins of those lost worlds, buried deep beneath newer layers of rock. The memory of these vanished continents survives only in the faint chemical signatures found in ancient minerals, tiny hints that Earth's early surface was constantly remade in fire. Life's emergence in this violent world remains one of the greatest mysteries of all. Somehow, in a planet still recovering from bombardment and fire, the first simple cells arose. Were they sparked in volcanic vents at the bottom of the ocean, where heat and minerals created a chemical cradle? Were they carried here by comets from distant worlds? Or did they arise in shallow pools, where lightning and ultraviolet light provided the spark of chemistry? We may never know, but what is certain is that life began at a time when Earth was anything but welcoming. To survive in a world of constant bombardments, shifting continents and unstable climates, those first cells had to be resilient, adapting to extremes we can barely imagine. Their survival is the reason we are here to ask these questions at all. And this is the chilling truth. Earth's origin is not a story of peace, but of repeated near destruction. Every step toward stability was built on catastrophe. The moon we see at night is a monument to a collision that nearly annihilated us. The oceans we depend on were born in fire and chaos. The continents we walk on are the survivors of countless cycles of creation and destruction. Even life itself arose not in comfort, but in adversity. The Earth we call home is the product of impossibility, a place that should not have endured, and yet somehow did. What makes this origin even more unsettling is how fragile it all was. If the collision with Theia had been slightly different, Earth might have been destroyed entirely. If the sun's faintness had not been offset by unknown forces, the oceans would have frozen solid. If life had not adapted quickly enough to a hostile world, it might never have gained a foothold. The fact that we exist is not proof of inevitability, it is proof of chance, of survival against impossible odds. Earth's origin story is not a guarantee of safety. It is a reminder that everything we know is balanced on the edge of chaos. And perhaps the most haunting thought of all is this: if Earth began in fire, violence, and instability, what does that say about its future? The same forces that shaped it then, collisions, volcanism, shifting climates, are still with us today. The story of Earth's impossible origins is not just ancient history. It is a warning that creation and destruction are inseparable, and that the planet beneath our feet has never truly been at peace. The question is not whether catastrophe will come again, but when. When we think of Earth's atmosphere, it feels permanent, like an invisible blanket wrapped safely around us. We breathe it without thought. We look up into the sky and see it painted with clouds, and we trust that it will always be there. But the truth is that Earth's atmosphere is far from stable. It is delicate, fragile, and constantly threatened by forces both within and beyond our world. To understand just how precarious this thin layer of gases is, we have to look at its past, its near disasters, and the strange possibilities that haunt its future. The earliest version of Earth's atmosphere looked nothing like the air we breathe today. It wasn't filled with oxygen, and it wasn't even safe for most modern life. Instead, it was dominated by carbon dioxide, methane, ammonia, and nitrogen, thick, suffocating gases released by relentless volcanic eruptions. The air was toxic, the sky likely a murky orange or red, and the world beneath it was boiling with oceans of lava. Breathing in that air would have been impossible for us, but it created the foundation for something unexpected, the chemical soup in which life itself would emerge. Over time, volcanic gases combined with water vapor from comets and minerals, and the atmosphere began to transform. But survival was never guaranteed. In fact, there were moments when Earth almost lost its air entirely. One of the greatest dangers comes from above, in the form of the solar wind, a constant stream of charged particles blasted from the sun. Without protection, this solar wind can strip away a planet's atmosphere, leaving it barren. We see the evidence in our solar system today. Mars once had flowing rivers and a thicker atmosphere, but without a strong magnetic shield, the solar wind tore it away. Now Mars is a cold desert, its air so thin it can barely cling to its own surface. Earth could have shared the same fate if not for one crucial defense: our magnetic field. Generated deep within the planet's molten core, this invisible shield deflects much of the solar wind, protecting the fragile gases we rely on. But even this protection is not perfect. Scientists have found that Earth still leaks atmosphere into space, with hydrogen and helium particles drifting away. It's a slow process, but it raises chilling questions. What if the magnetic field weakens too much? What if, like Mars, our planet loses its ability to hold on to the air we need? The magnetic field is not the only factor shaping our atmosphere. Oxygen, the very gas we depend on most, has a strange and unstable history. For nearly 2 billion years, oxygen barely existed in the atmosphere at all. Early life forms, tiny microbes, thrived in its absence. Then around 2.4 billion years ago, something extraordinary happened: the Great Oxidation Event. Microbes began releasing oxygen as waste through photosynthesis, and slowly the atmosphere began to fill with it. At first, oxygen was deadly to most organisms that had adapted to a low-oxygen world. Entire species were wiped out in what some call the first mass extinction, caused not by asteroids or volcanoes, but by the air itself becoming toxic. Only life that could tolerate or use oxygen survived, and from there, new forms of complexity began to evolve. Oxygen brought possibility, but it also brought instability, a reminder that the atmosphere is not a gentle friend. It is a force that can kill as easily as it can sustain. Even after oxygen took hold, it has never been constant. At times in Earth's history, oxygen levels soared higher than today, fueling bizarre evolutionary experiments: insects the size of birds, dragonflies with wingspans longer than human arms, and forests that burned with terrifying ease because oxygen-rich air made fire nearly unstoppable. At other times, oxygen levels plummeted, suffocating ecosystems and collapsing entire food chains. The atmosphere has always walked a fine line between too little and too much, and its changes have shaped life in ways more dramatic than any other force. Carbon dioxide tells a similar story. It is easy to think of it only as a modern problem, tied to human industry, but carbon dioxide has always been a central player in Earth's drama. In the distant past, volcanic eruptions spewed massive amounts into the air, triggering global warming events so extreme that oceans turned toxic and ecosystems collapsed. At other times, weathering of rocks or massive plant growth pulled carbon dioxide down, plunging Earth into ice ages where glaciers reached the equator. The balance between carbon dioxide and oxygen, between warming and cooling, is precarious. The rocks and ice hold clear evidence. When the balance tips too far in one direction, catastrophe follows. And today, we are repeating the same dangerous patterns, only faster. Humanity is pumping carbon dioxide into the atmosphere at a rate that rivals or even surpasses some of Earth's greatest natural upheavals. The ice cores from Antarctica and Greenland show the cycles of carbon stretching back hundreds of thousands of years. Never in that record has there been a spike as sharp and as rapid as the one we are causing now. The warning is clear. The atmosphere remembers, and it punishes imbalance. Yet there are other mysteries of our fragile atmosphere that scientists are only beginning to unravel. For example, there are high-altitude phenomena known as sprites, elves, and blue jets. Strange electrical discharges in the upper atmosphere, so fleeting they were unknown to science until the last few decades. These bizarre flashes remind us that we still do not fully understand the layers of air above us. Even more unsettling are unexplained sounds, low-frequency hums and booms that seem to originate from the atmosphere itself, heard in different parts of the world with no clear source. Some suggest they are linked to shifting air currents, others to secret geological processes, but the truth remains elusive. The atmosphere may hold more secrets than we realize, its mysteries hidden in the very air we breathe. The fragility of Earth's atmosphere becomes even more apparent when we compare it to other worlds. Venus, with an atmosphere so thick and toxic that surface temperatures can melt lead, is a vision of what happens when carbon dioxide runs out of control. Mars, stripped of its air by the solar wind, is a desert frozen under a thin blanket of carbon dioxide. Earth exists between these extremes, in a narrow balance that feels permanent, but is anything but. We are suspended between suffocation and desolation, and that balance has tipped before. The most chilling truth is that the atmosphere, which feels eternal to us, is temporary on a cosmic scale. It has changed radically in the past. It is changing now, and it will change again in the future. The air that fills our lungs is not guaranteed. It is a gift balanced on forces we barely control: volcanoes, oceans, microbes, and a magnetic shield that drifts and weakens over time. Earth's fragile atmosphere is not just a backdrop to our lives. It is the thin, delicate thread that holds life together, and threads can fray. The rocks, the ice, and the air itself all carry the same message. This balance has been broken before, and when it breaks, the consequences are unimaginable. Earth's atmosphere is not a promise. It is a warning, and the question is not whether it can change, but how quickly it will and whether we will survive the change when it comes. When we picture Earth's oceans, we think of the vast blue expanses that cover most of the surface, Pacific waves crashing on rocky cliffs, the endless horizon of the Atlantic, the icy waters of the Arctic. But what if I told you those oceans might be just the surface layer of something far larger, far stranger, and far more hidden, deep beneath our feet, buried not just miles, but hundreds of miles under the crust? Scientists believe there are reservoirs of water so massive they could dwarf all the seas we know. These aren't oceans in the way we imagine them, with whales breaching and coral reefs glowing. They are trapped inside rock itself, locked within minerals under crushing pressure, forming a hidden world of water that could change everything we think we know about the planet. The first hints of these underground oceans came not from direct observation, because no human or machine has ever dug deep enough to see them, but from the behavior of seismic waves. When earthquakes strike, their vibrations ripple through the earth, bouncing, bending, and slowing as they pass through different materials. By carefully studying these patterns, scientists realized something strange. Some regions deep below the surface slowed seismic waves in ways that suggested the presence of water. Not liquid water in open pools, but water bound within the crystal structures of minerals like ringwoodite. The discovery was shocking. An entirely new reservoir of water hidden in plain sight, beneath the crust we walk on every day. In 2014, the suspicion became evidence. A diamond from deep within the earth, brought up by a volcanic eruption in Brazil, was found to contain tiny inclusions of ringwoodite. Inside that mineral were traces of water, proof that deep beneath us, the mantle is not dry but infused with water at an unimaginable scale. The estimates are staggering. Some scientists believe this hidden ocean could contain as much as 3 times the amount of water found in all of Earth's surface oceans combined. Think about that for a moment. The familiar oceans we see, which already cover 70% of Earth, might be just a thin veneer compared to the vast stores of water buried below. This discovery raises unsettling questions. If so much water lies beneath us, how does it interact with the surface world? Some theories suggest that deep water cycles through the earth in ways we are only beginning to understand. Subducting tectonic plates carry water down into the mantle, where it becomes locked into minerals. Over millions of years, volcanic eruptions and other geological processes release some of that water back into the air, fueling the balance of oceans and atmosphere. In other words, Earth is not just a planet with oceans, it is a planet that breathes water, inhaling and exhaling it over geological time. And what happens if this hidden ocean is disturbed? Could massive releases of deep water fuel catastrophic eruptions or even reshape continents? Some scientists speculate that the deep water cycle might be linked to supervolcanoes, those rare eruptions powerful enough to blanket the globe in ash and plunge the planet into years of darkness. The pressure of water deep underground could influence how magma moves, when eruptions occur, and how devastating they become. If true, then these hidden oceans are not just passive reservoirs. They are active participants in Earth's most destructive events. The existence of vast underground oceans also changes how we think about the origin of water on Earth. For decades, scientists debated whether our water came primarily from comets and asteroids delivering ice during the early years of the solar system. But if water has always been locked deep within the mantle, then perhaps Earth was born wet, carrying its own supply from the very beginning. This idea challenges long-held assumptions and forces us to reconsider the timeline of oceans, life, and stability on our planet. Even more fascinating is what these hidden oceans could mean for the possibility of life. On the surface, water is the foundation of biology. Every known form of life depends on it. If water exists deep within the planet, could there be forms of life that survive far below, in darkness and pressure beyond imagination? We already know of extremophiles, organisms that thrive in boiling vents on the seafloor, in acidic pools, even in radioactive environments. Could some microscopic survivors exist within the deep water-rich mantle, feeding off chemical reactions where no sunlight has ever reached? We have no evidence yet, but the possibility lingers. Haunting and tantalizing life might not just exist on Earth's surface, but within its hidden depth. Of course, these hidden oceans remind us of fragility as much as mystery. If Earth truly stores this much water underground, then the balance of surface oceans and climate may depend on processes we cannot see or control. A shift in how much water is stored below versus released above could alter sea levels, climate stability, and even the chemistry of our atmosphere. The system that sustains us may be tied to hidden forces we barely understand. What makes this even more unsettling is that other planets may have similar secrets. Jupiter's moon Europa and Saturn's moon Enceladus are known to harbour oceans beneath their icy shells, heated by internal forces. If Earth also hides oceans within its rock, then perhaps this kind of hidden water is common in the universe. And if hidden water is common, then maybe life itself is more widespread than we dare to imagine. Earth's buried oceans are not just part of our story. They may be a clue to the story of life everywhere. Yet for all the promise and wonder, the reality is stark. We cannot reach these oceans. They are buried hundreds of miles below, under pressures so intense that steel would collapse like paper. They are invisible, detectable only through faint signals in seismic waves and tiny inclusions in diamonds. Their existence is real, but they remain out of reach, like whispers from another world. And perhaps that is why they haunt us. We know they are there, we know they are vast, and yet they remain untouchable, a reminder that Earth still hides secrets from us, even in an age when we think we've mapped and measured every inch of the globe. The hidden oceans beneath Earth are a paradox. They are invisible, yet larger than the seas we know. They are buried, yet they shape the surface world. They are ancient, yet they may still be active, influencing eruptions, earthquakes, and the very balance of climate. To learn that our world is hollowed with water is to realize that Earth is not as solid or as simple as it appears. It is layered, restless, and filled with mysteries we are only beginning to uncover. And that leads to the most unsettling question of all. If we are just now discovering oceans beneath our feet, what else might Earth be hiding from us? The deeper we look, the more it seems that this planet is not a familiar home, but an enigma, filled with secrets waiting to be revealed. Perhaps one day, through new technology or new disasters, we will uncover more. Until then, the hidden oceans remain a ghostly reminder that Earth is stranger, vaster, and more mysterious than we ever dared to believe. Deep beneath the crust and mantle, farther than any drill has ever reached, lies Earth's core, the beating heart of our planet. A place so extreme that it defies imagination. No human will ever see it directly. No machine could survive its crushing pressure or blistering heat. And yet without it, life on Earth would not exist. The core is both protector and threat, the source of our magnetic shield and the keeper of a hidden violence that occasionally shakes the surface in catastrophic ways. To understand Earth is to confront the mystery of the core, and it is a mystery that continues to unsettle even the most brilliant scientists. The core is divided into two parts. The outer core, a swirling ocean of molten iron and nickel, and the inner core, a solid sphere of mostly iron that spins independently from the rest of the planet. Temperatures there reach up to 10,000 degrees Fahrenheit, as hot as the surface of the sun. Pressure is so intense that atoms themselves are forced into strange, exotic states of matter. And yet, despite these extreme conditions, the core is not static. It is restless, dynamic, and alive with movement. The liquid outer core churns constantly, its flows of molten metal generating Earth's magnetic field through a process known as the geodynamo. This invisible shield stretches far into space, deflecting deadly solar winds and cosmic radiation that would otherwise strip away our atmosphere and sterilize the surface. Without the core's protection, Earth would be as barren as Mars, our oceans boiled away and our skies blasted into emptiness. But this guardian is not eternal. Scientists have discovered that the core is slowly cooling, losing heat into the mantle and crust above. One day, perhaps billions of years in the future, the outer core may solidify completely. The geodynamo will die, and Earth's magnetic shield will collapse. When that happens, life on the surface will face radiation and destruction beyond imagination. The very heart that sustains us will one day become our undoing. Yet even now, in its active state, the core is unpredictable. Every so often the magnetic field weakens, shifts, or even flips entirely, with north and south trading places in a phenomenon called magnetic reversal. These reversals are recorded in ancient rocks, showing a chaotic history of shifting poles. Some reversals happened rapidly, in less than a human lifetime. The thought is chilling. If such a reversal occurred today, satellites would fail, power grids would collapse, navigation systems would spin into chaos, and radiation levels would rise dangerously. Our civilization is deeply dependent on a magnetic shield we barely understand, and there are stranger mysteries still. Recent studies suggest that the inner core might not be a perfect solid sphere but a place of strange phases, with regions softer than expected, or even partially molten. Some research even points to the possibility that the inner core spins at a slightly different rate than the rest of the Earth, creating a second hidden rhythm beneath our feet. Imagine that our world is not spinning on one axis but on two, with the surface and the deep heart moving in subtle opposition. The implications are staggering. Could these differential spins influence earthquakes? Could they affect the stability of the magnetic field? We don't know, and the uncertainty leaves us with more questions than answers. One of the most unnerving aspects of the core is how little we can measure directly. Everything we know comes from indirect evidence: seismic waves rippling through the planet, tiny variations in gravity, faint signals from magnetic disturbances. The picture we build is always incomplete, always open to revision. Just a few years ago, scientists discovered evidence of a possible innermost inner core, a sphere within the sphere, with a different structure than the outer inner core. It is as though the planet is layered with secrets, each one hidden within another, an onion of iron and fire that refuses to reveal itself fully. This hidden heart also connects to some of the most devastating events in Earth's history: massive volcanic eruptions, continental drift, and even the breakup of supercontinents may be linked to heat rising from the core, pushing the mantle into convulsions. Some of the largest extinction events in history, including the Great Dying 252 million years ago, may have been fueled by mantle plumes driven from deep within. In this sense, the core is not just a passive center but an engine of catastrophe, shaping the surface in ways that can wipe out most of life. To realize this is to see the duality of the core. It protects us through its magnetic shield, but it also threatens us through the geological violence it powers. And yet, even as we uncover more about this fiery heart, new mysteries emerge. Why does Earth have a core that remains molten while smaller planets like Mars have cores that have cooled and solidified? Why is our magnetic field so much stronger than Mercury's, despite Mercury being closer to the Sun? And most haunting of all, could the core suddenly shift in ways we cannot predict? Some scientists warn that changes in the core's flow patterns might trigger partial collapses of the magnetic field, events that would leave Earth vulnerable to space weather and plunge our technological civilization into chaos. It has happened before, in smaller ways, and it will happen again. The only uncertainty is when. Perhaps the most chilling thought is this: the core is alien to us. We can never touch it, never drill to it, never see it with our eyes. It is an entire world beneath our world, operating on timescales we cannot comprehend, shaping the fate of every living thing while remaining forever hidden. Our lives, our history, our entire species rests on the restless movements of a place we cannot reach and do not fully understand. The Earth may feel solid beneath our feet, but deep down it is liquid, turbulent and unknowable. And so the mystery of the core endures. It is the ultimate paradox, the most important part of Earth, and yet the most inaccessible. It is our protector, and yet also the root of destruction. It is steady, and yet restless. It is familiar, and yet alien. And as long as we live on this planet, its heartbeat will decide our fate in ways both subtle and catastrophic. The core is a reminder that Earth is not a finished, static place. It is alive, dangerous, and filled with secrets we may never uncover. The question is not whether the core will surprise us again, but how, and whether we will be ready when it does. If you trace the history of life on Earth, you don't find a straight line of progress from simple cells to complex beings like us. Instead, you see a jagged record of survival and destruction, of growth interrupted by catastrophe, of worlds erased and restarted again and again. Life's journey is not just about evolution. It is about extinction. And what's most chilling is that mass extinctions are not rare, isolated accidents. They are woven into the very fabric of Earth's history. Without them, the world would look nothing like it does today, and we humans might never have appeared at all. But the same force that made our existence possible could also erase us in an instant. At least 5 times in Earth's history, life has been pushed to the brink by cataclysms, so vast they reset the planet entirely. The first of these great extinctions, about 443 million years ago, struck during the Ordovician period. At that time, most life lived in the oceans, and those oceans suddenly turned hostile. A rapid global cooling, followed by intense glaciation, trapped water in massive ice sheets, lowering sea levels and destroying marine habitats. Nearly 85% of species were wiped out, an almost total collapse of ocean ecosystems. It was the first reminder that Earth's climate is not stable, and that life exists at the mercy of forces far beyond its control. The second great extinction, around 35 million years ago during the Devonian period, is sometimes called the Age of Fish, because the seas were filled with armored giants and strange predators. But it ended in disaster. Over the course of several million years, repeated pulses of extinction eliminated nearly 75% of species. Some scientists point to widespread volcanic activity and climate change. Others blame the spread of plants on land, which may have drawn down carbon dioxide and altered atmospheric balance. Whatever the cause, the oceans turned toxic, oxygen levels plummeted, and once thriving ecosystems collapsed. Evolution's grand experiments were erased, and only the hardiest survivors remained. But the third extinction dwarfs all others. About 252 million years ago came the Permian-Triassic extinction, the Great Dying. This was the most devastating event life has ever faced. Up to 96% of marine species and 70% of land species vanished. Entire lineages were obliterated, forests collapsed. Insects, usually resilient, were almost wiped out. The cause appears to have been massive volcanic eruptions in Siberia, which unleashed unimaginable amounts of carbon dioxide and methane into the atmosphere. The planet heated drastically, oceans acidified, and oxygen levels dropped so low that vast regions became dead zones. For millions of years, Earth was nearly lifeless, a silent planet where only a handful of species clung to exist. If extinction events are planetary resets, this one was the ultimate hard reboot. Life itself almost didn't recover, but it did. Out of that devastation came new beginnings. The survivors of the Great Dying paved the way for the rise of the dinosaurs, who would dominate the planet for more than 150 million years. Yet their reign, too, ended in catastrophe. The fourth extinction, around 2,000 million years ago, struck at the boundary between the Triassic and Jurassic periods. Again, volcanic eruptions appear to be the trigger, this time linked to the breakup of the supercontinent Pangaea. Massive outpourings of lava released greenhouse gases, warming the planet and altering ecosystems. Nearly half of all species disappeared. But once more, extinction cleared the stage for something new. In this case, the dinosaurs' uncontested rule. For tens of millions of years, the dinosaurs seemed unstoppable. They grew to enormous sizes, filled every niche, and spread across every continent. But even they were not immune. About 66 million years ago came the fifth and most famous extinction, the one that ended their reign. A massive asteroid, at least 6 miles wide, slammed into what is now the Yucatan Peninsula in Mexico. The impact unleashed energy equal to billions of nuclear bombs, igniting fires across the globe and sending dust and sulfur into the atmosphere. Sunlight dimmed, temperatures plummeted, and ecosystems collapsed. Within a few years, 3/4 of all species were gone, including the non-avian dinosaurs. Yet once again, life rebounded. With the dinosaurs gone, mammals, small furry survivors of earlier ages, rose to prominence, setting the stage for primates and eventually for us. The pattern is clear. Extinction is not the end of life. It is the end of one chapter and the start of another. Each reset clears the board, erases the dominant players, and gives new forms a chance to rise. Without these catastrophes, humans likely would never have evolved. The asteroid that killed the dinosaurs made space for our ancestors. The volcanic eruptions that devastated earlier worlds made room for new ones. Extinction is both a destroyer and a creator, merciless but essential. And yet, for us, this truth carries a dark edge, because if extinctions are inevitable, then humanity is not immune. Our chapter 2 could be erased. Even outside of the Big Five, smaller extinction events have shaped the world in profound ways. The ice ages forced species to adapt or die. Shifts in ocean circulation triggered rapid climate changes that collapsed ecosystems. Volcanic supereruptions blanketed skies in ash, dimming the sun for years. Again and again, life has been forced to restart, to adapt, to evolve in the aftermath of destruction. Every time, the world that emerged was different from the one that came before. Evolution is not a steady climb. It is a series of leaps, driven by survival after catastrophe. Today, some scientists warn that we may be living through a sixth great extinction, one not caused by asteroids or volcanoes, but by ourselves. Human activity, deforestation, pollution, overfishing, climate change is driving species to extinction at a rate unseen in millions of years. Amphibians, birds and mammals vanish daily, while coral reefs, the rainforests of the sea, are dying rapidly. The question is no longer whether mass extinction is coming. It is whether we are its architects. If true, it would make us not just the victims of Earth's resets, but the cause. And yet, the haunting truth remains. Even if humans vanished tomorrow, the planet would go on. Life would recover, reshape, and thrive again, just as it always has. We are not the masters of Earth. We are one more chapter in its vast story of creation and destruction. Extinction teaches us that nothing is permanent, not dominance, not stability, not even survival itself. When we look back at Earth's history, what we see is not a tale of inevitability, but of chance. If the asteroid 66 million years ago had missed, dinosaurs might still rule, and humans might never have evolved. If the Great Dying had been even more severe, life might have ended altogether. The fact that we exist at all is the result of countless extinctions, each one a reset that opened the door for something new. It is humbling, and it is terrifying. And maybe the most disturbing thought of all is this: the forces that caused those past extinctions are still here. Asteroids still cross Earth's orbit, supervolcanoes still simmer beneath the crust. Climate can still shift violently. Extinction is not just history, it is the future. The only uncertainty is whether we will adapt, or whether we will be erased and replaced, just as so many species before us have been. If there is one lesson Earth has taught us through its long history, it is that nothing stays the same for long. Our planet is a pendulum, swinging between extremes, and nowhere is that more obvious than in the cycles of ice and fire that have shaped its destiny. These cycles are not gentle. They are brutal resets that ultimately freeze and burn the world, reshaping oceans, land, and life itself. When Earth tips toward ice, glaciers march across continents, swallowing entire landscapes under walls of frozen silence. When it tips toward fire, volcanic eruptions belch gas and ash into the sky, heating the atmosphere and igniting mass die-offs. Together, these cycles of ice and fire remind us that Earth is not a stable home but a restless giant, forever teetering on the edge of transformation. One of the most dramatic examples of Earth's icy extremes is the theory of snowball Earth. Around 700 million years ago, during the Cryogenian period, glaciers didn't just cover the poles. They may have swallowed the entire planet. Imagine standing anywhere on Earth and seeing nothing but a frozen horizon, oceans locked under miles of ice, sunlight reflected back into space, and temperatures plummeting. Life at that time was mostly microscopic, and yet somehow it endured this planetary deep freeze. The evidence lies in rocks scarred by glacial movement found near the equator, proof that ice once reached tropical regions. How life survived such a frozen prison is one of Earth's great mysteries. Perhaps volcanic activity beneath the ice kept pockets of water liquid, serving as refuges for primitive organisms. Or perhaps life clung on in the deep sea, near hydrothermal vents that provided heat and nutrients when the surface froze. Whatever the case, the fact that life persisted through a global ice age speaks to its resilience, but also to the fragility of Earth's balance. If ice represents one end of the pendulum, fire represents the other. Volcanic eruptions have been some of the most transformative forces in Earth's history, capable of changing climate on a global scale. Supervolcanoes like the one beneath Yellowstone or the ancient eruptions in Siberia can release so much gas and ash that they plunge the world into chaos. When the Siberian traps erupted about 252 million years ago, they may have burned through massive coal beds, releasing vast amounts of carbon dioxide and methane. The result was runaway warming, suffocating oceans, and the greatest extinction in Earth's history, the Great Dying. Fire does not just reshape landscapes, it can erase entire worlds. And while ice tends to silence life slowly, Fire can snuff it out in violent bursts that leave the planet gasping. But what makes these cycles truly terrifying is how they intertwine. Ice ages and warming periods do not occur in isolation. They are part of a complex rhythm driven by Earth's orbit, the tilt of its axis, the chemistry of its atmosphere, and the hidden churn of its mantle and core. These cycles play out over tens of thousands, hundreds of thousands, even millions of years. The last ice age, which ended about 12,000 years ago, left its scars on the land in the form of valleys carved by glaciers, massive freshwater lakes, and fertile soils. Humanity itself is a child of that ice age. Our ancestors learned to survive in harsh frozen environments, and when the ice retreated, the warming climate allowed agriculture to flourish, civilizations to rise, and history to unfold. The world we know today is the fragile aftermath of fire and ice doing battle for control. The haunting truth is that these cycles are not over. We live in what scientists call an interglacial period, a brief warm spell between longer ages of ice. If history is a guide, glaciers will return, swallowing cities, rivers, and plains. It may not happen for tens of thousands of years, but in Earth's grand timeline, that is the blink of an eye. And even before the glaciers march again, fire still lurks beneath us. Supervolcanoes still simmer, capable of eruptions that could block sunlight for years, plunge the world into volcanic winter, and collapse global food supplies. We may tell ourselves that we live in a stable climate, but history says otherwise. We live on borrowed time, balanced precariously between ice and fire. What makes the cycles even more disturbing is that sometimes they strike in combination, amplifying one another. A massive eruption can trigger cooling by releasing sulfur particles into the atmosphere that reflect sunlight, but the carbon dioxide from that same eruption can also drive long-term warming, pushing Earth from cold to hot in a geological instant. Likewise, glacial periods can alter the weight distribution on Earth's crust, releasing pressure on magma chambers and triggering volcanic activity. In this way, ice and fire are not just opposites, they are partners, locked in a destructive dance that has shaped Earth for billions of years. We like to think of extinction as random, as the result of unlucky asteroids or freak events. But when you step back, you see a pattern. Earth itself is the engine of destruction. It freezes, it burns, it resets, and life must adapt or die. Humanity has only existed for a brief moment in this long cycle, and already we've experienced glimpses of its power. The eruption of Mount Tambora in 1815 caused the year without a summer, plunging much of the world into cold, famine, and darkness. Imagine that, magnified 100 times, lasting not for months, but for decades. That is the scale of catastrophe Earth's cycles can deliver. And yet, in the aftermath of these catastrophes, life always rebounds. Snowball Earth thawed, paving the way for multicellular life to flourish. The Great Dying ended, and dinosaurs rose. The last ice age retreated, and humans thrive. Fire and ice destroy, but they also clear the stage for new beginnings. In that sense, they are not just enemies of life, but also its unlikely allies, pushing evolution forward, forcing adaptation, and driving innovation in the struggle to survive. Still, the lesson for us is sobering. These cycles will continue, with or without us. Humanity is not outside of Earth's rhythms. We are caught in them, dependent on them, and vulnerable to them. We can build cities, invent technologies, and dream of conquering the stars, but we cannot stop the glaciers from advancing, nor can we silence the fire beneath our feet. The best we can do is understand these cycles, prepare for them, and accept that Earth is not a gentle home but a restless force. Perhaps the most chilling realization is that while Earth has endured billions of years of ice and fire, species have not. Extinctions are the rule, not the exception. Survival is temporary, and if we are honest, humanity's time will eventually end, swept away by the same cycles that erased so many before us. The question is not if, but when, and whether we will leave behind a legacy that endures beyond the ice and fire. We take for granted that north is north and south is south, that a compass will always point reliably, that Earth's magnetic field is a steady and invisible guardian. But the truth is far more unsettling. The magnetic field is not fixed, not stable, and not eternal. It wobbles, it weakens, it shifts, and sometimes it even flips entirely. Imagine waking up in a world where compasses no longer work, where satellites fail, where navigation collapses, and where cosmic radiation floods the atmosphere because our magnetic shield falters. This isn't a work of fiction. It's a reality written into the history of the Earth, and it will happen again. The only question is when. The magnetic field exists because of Earth's core, that restless ocean of molten iron in the outer core flowing around a solid inner heart. This motion generates electric currents, which in turn produce the magnetic field through the geodynamo effect. For billions of years, this shield has protected us from solar winds and cosmic rays, deflecting deadly radiation that would strip away our atmosphere and boil away our oceans. Without it, Earth would resemble Mars, a barren, lifeless desert world. But as much as we rely on this shield, it is unstable. Records preserved in volcanic rocks show that throughout Earth's history, the poles have flipped hundreds of times. What we think of as north has not always been north. Sometimes it was south, and sometimes the field was so chaotic that compasses would have spun uselessly in every direction. The most recent major reversal, known as the Brunhes-Miyajima reversal, happened about 720,000 years ago. To us, that feels like an eternity, but in geological time it is the blink of an eye. Even more unsettling are geomagnetic excursions, temporary collapses of the field where strength plummets without a full reversal. One of the most famous, the Lachamps excursion, occurred just 42. During this period, Earth's magnetic field weakened to as little as 10% of its current strength. Cosmic radiation surged into the atmosphere, increasing auroras to the tropics, altering climate patterns, and possibly even stressing human population. Imagine being a hunter-gatherer under skies alive with strange lights, feeling the cold bite of shifting weather, never knowing that the cause was deep within the Earth itself. Some scientists speculate that the Lachamps excursion may have contributed to the disappearance of Neanderthals, who lived in Europe at that time. With radiation levels higher and climates more unstable, survival would have been harder, especially for populations already pushed to the edge. If that's true, then magnetic chaos has not just shaped the physical Earth, it may have shaped human history itself, altering which species endured and which vanished. And here's the part that should make us uneasy. The magnetic field has been weakening for the past 2 centuries. Since we began measuring it, its strength has dropped by about 10%, and a strange region of instability called the South Atlantic anomaly has appeared, stretching from South America to Africa. In this zone, the field is significantly weaker, and satellites passing overhead often suffer radiation damage. It is as if Earth's shield has a growing crack. No one knows if this is the start of a full reversal, or just another temporary fluctuation, but the possibility is real. If a collapse occurred today, the consequences would be devastating. Modern civilization depends on technologies that rely on the magnetic field and protection from solar radiation. A weakened shield would expose satellites to constant bombardment, knocking out GPS communications and weather monitoring. Solar storms, which the field normally deflects, could slam into Earth's power grids, frying transformers and plunging entire countries into darkness for months or even years. Radiation levels at the surface could rise enough to threaten high-altitude flights, astronauts and sensitive electronics. The magnetic chaos that once terrified primitive humans with auroras and climate shifts could now collapse the infrastructure of global civilization. But even beyond the technological dangers, there is a deeper mystery. Why does the field flip at all? The geodynamo is complex, influenced by the flows of molten iron, the spin of the Earth, and the cooling of the core. Small instabilities can cascade, causing the field to weaken and reorient itself. Yet no model fully explains the pattern. Sometimes reversals are frequent. Sometimes millions of years pass between them. Sometimes they happen gradually. Sometimes in just a few centuries. The unpredictability is terrifying. We know a reversal will happen again, but we cannot say when, how fast, or how severe. There's also the possibility that a reversal is not the worst-case scenario. Some studies suggest that during reversals, the field does not vanish completely but instead becomes multipolar, with several north and south poles scattered across the globe. Imagine standing in Europe and finding your compass points north to Africa, while in Asia it points to Alaska. This chaos could last for centuries, leaving the planet vulnerable to radiation all the while. Life has survived these reversals before, but in a pre-technological world. For us, the challenge is not just survival but maintaining the fragile systems we depend on. The magnetic field also raises unsettling questions about Earth's future. As the core cools and changes, will the field grow weaker overall? Will reversals become more common? Could a complete collapse occur, leaving Earth permanently without a shield? If that were to happen, solar winds would slowly strip away the atmosphere just as they did on Mars. Oceans would evaporate, climates would collapse, and Earth would become unrecognizable. It may sound like a distant nightmare, but the process of core cooling is real, and the shield that protects us will not last forever. What makes all this even more haunting is that we are powerless to stop it. We can study the core through seismic waves, we can measure the field's strength with satellites, we can model its behavior with supercomputers, but we cannot touch it, control it, or prevent its shifts. The heart of Earth moves on its own schedule, indifferent to our survival. When it chooses to flip or weaken, we will be forced to endure the consequences. The story of magnetic shifts is not one of gentle changes, but of chaos, uncertainty, and fragility. It reminds us that even the invisible structures we rely on can collapse without warning. Compasses that guided explorers, shields that protected life, fields that allowed our civilization to flourish. These are temporary gifts from a restless planet, and just as they have failed before, they will fail again. Perhaps the most chilling thought is that the signs are already here. The weakening field, the growing anomaly, the unpredictable behavior, they all suggest that change is underway. Maybe it will stabilize, maybe not. But history tells us one thing with certainty. The field will flip again, and when it does, the world as we know it will be thrown into chaos, forcing us to confront once more the terrifying truth that Earth is not a steady home, but a shifting, unstable, and dangerous one. The ground beneath our feet feels solid, dependable, and safe. We build cities, carve roads, raise skyscrapers, and walk through life rarely thinking about the fact that everything rests on shifting plates of rock that float on a restless mantle. But this stability is an illusion. The Earth is constantly moving, cracking, and grinding, its energy stored in unseen faults until it releases in violent bursts we call earthquakes. These events strike without warning, toppling cities, reshaping landscapes, and reminding us that beneath the surface, Earth is never at rest. What makes earthquakes so terrifying is not just their destructive power, but their unpredictability. They emerge from the invisible, from faults that are often buried deep, forgotten, or undiscovered, until they rupture with devastating force. The theory of plate tectonics explains why earthquakes happen. Earth's crust is broken into massive plates that move slowly but relentlessly, pushed by the churning currents of the mantle below. Where these plates meet, they grind past, collide, or pull apart, creating zones of tension and release. The San Andreas Fault in California, where the Pacific Plate and North American Plate slide past each other, is one of the most infamous examples. Scientists know it is capable of producing the big one, a quake so massive it could cripple infrastructure across the state. Yet despite decades of study, no one can say when that quake will strike or whether it will come tomorrow, next year, or decades from now. This uncertainty is what keeps populations living above these faults in a constant state of uneasy denial. But some of the most dangerous earthquakes do not come from the well-known faults. They strike from the unseen, from hidden fractures buried deep beneath sediment or long thought inactive. The 1811 and 1812 New Madrid earthquakes in the central United States are a chilling example. Occurring far from any major plate boundary, they were so powerful, they caused the Mississippi River to flow backward for a time. Entire forests sank, new lakes formed, and aftershocks rattled the region for months. Today, tens of millions of people live in the Mississippi Valley, largely unaware that this hidden fault could awaken again. Unlike California, where earthquakes are expected, places like this are unprepared, making them even more vulnerable. Other unseen dangers lurk around the globe. In 2001, the Bhuj earthquake in India struck in a region thought to be stable, killing more than 20,000 people and destroying entire cities. In 2008, the Sichuan earthquake in China revealed a hidden fault beneath the Longmen Range, collapsing schools and homes and killing nearly 90,000 people. These disasters highlight the terrifying reality: many of Earth's faults remain unmapped. We don't know where all the danger lies, and even in places we do, we cannot predict the timing. Earthquakes remain one of nature's most unpredictable killers. Adding to the terror is the cascading nature of earthquake disasters. A quake rarely comes alone. It often triggers landslides, tsunamis, and fires. The 2011 Tohoku earthquake in Japan, one of the most powerful ever recorded, unleashed a tsunami that swept across coastal towns, destroyed nuclear power plants, and left lasting scars on the nation. The shaking was catastrophic, but the water that followed was worse. Thousands were swept away in minutes, entire towns erased, and radioactive contamination spread across the landscape. Earthquakes reveal how interconnected Earth's systems are. A shift in rock beneath the ocean can unleash waves that cross the entire Pacific, destroying cities thousands of miles away. What makes earthquakes even more haunting is the scale of energy involved. A large quake can release energy equivalent to thousands of nuclear bombs, and yet all of that power comes from rocks sliding a few meters along a fault. The fragility of our civilization becomes painfully obvious when highways crack open, skyscrapers sway like reeds, and entire neighborhoods collapse under the weight of their own foundations. We imagine Earth as solid and enduring, but earthquakes remind us that it is fragile and violent, capable of unmaking our works in seconds. And the danger is not limited to known seismic zones. Megathrust earthquakes, the most powerful of all, occur at subduction zones where one plate dives beneath another. These quakes can exceed magnitude 9 and produce tsunamis that devastate entire coastlines. The 2004 Indian Ocean earthquake and tsunami, which killed more than 230,000 people across multiple countries, is a grim reminder of this power. But what's most terrifying is that other subduction zones, like the Cascadia subduction zone off the Pacific Northwest of the United States, remain ominously quiet. Scientists warn that Cascadia is capable of producing a quake as powerful as Tohoku or even larger, with a tsunami that could wipe out coastal cities from California to Canada. It has not ruptured in over 300 years, which in geological terms means it is due. Millions live in its shadow, unaware or unprepared for the day when the earth beneath them snaps. Yet earthquakes are not only destructive, they are also creative forces. Over millions of years, they build mountains, raise coastlines, and carve valleys. The Himalayas exist because of the collision between India and Eurasia, a collision that still produces devastating quakes today. Without earthquakes, Earth would not be the dynamic planet it is. It would be geologically dead, like Mars, frozen in time. But this creativity comes at a cost. For life to thrive on such a restless planet, it must endure the constant threat of destruction. And for humans, who build complex societies dependent on stability, that threat is existential. One of the most haunting aspects of earthquakes is how little warning they give. Unlike hurricanes or volcanoes, which show signs before they erupt, earthquakes strike suddenly. A rumble, a shudder, and then chaos. Efforts to create early warning systems have had some success. Japan and Mexico have networks that can detect initial tremors and send alerts seconds before the strongest shaking arrives. But seconds are all they can offer, enough to duck under a table or stop a train, not enough to prevent devastation. We cannot predict them days or weeks in advance, and perhaps we never will. The forces that trigger them lie too deep, too complex, too hidden for us to truly see. Even more disturbing is the possibility that human activity may sometimes trigger earthquakes. Hydraulic fracturing or fracking, along with the disposal of wastewater deep underground, has been linked to swarms of small to moderate quakes in regions that were once stable. Dams built across large rivers, which weigh down the crust with billions of tons of water, have also been linked to seismic activity. In this way, our own actions may be waking faults we never knew existed, adding another layer of danger to an already restless planet. And so we live on a knife's edge, walking each day across a crust that can rupture without warning, unleashing energy beyond imagination. Earthquakes remind us that the world is not ours to control. It is alive, unstable, and dangerous, and all of our cities, technologies, and ambitions are built on shifting ground. The hidden faults, the unseen cracks, the sudden release of pressure, these are the true foundation of our world, and they are foundations made not of stability, but of chaos. Perhaps the most sobering realization is this: earthquakes will never stop. They are part of what makes Earth Earth. Long after our species is gone, long after our cities crumble to dust, the ground will still shake, mountains will still rise, and oceans will still heave from the unseen fractures below. Earthquakes are not accidents, they are inevitability. And living on this planet means living with that inevitability, whether we choose to acknowledge it or not. Beneath the thin crust we call home lies a world of molten rock, simmering under unimaginable pressure, waiting for the right moment to break free. When it does, we call it a volcano, but that word barely captures the raw power of what's really happening. A volcanic eruption is not just fire spewing from a mountain, it is Earth tearing itself open, releasing the pent-up fury of the planet's interior. It can reshape landscapes in hours, bury cities in ash, blot out the sun, and even change the course of history. Volcanoes are both creators and destroyers, and their story is inseparable from the story of Earth itself. For millions of years, volcanoes have built continents, raised islands, and fertilized soils. Without them, the air we breathe and the oceans we sail would not exist. Early in Earth's history, it was volcanic activity that released gases from the interior, creating the first atmosphere. It was volcanoes that delivered water vapor, carbon dioxide, and other ingredients that eventually condensed into oceans. In many ways, we owe our existence to the fire below, but that same fire has also brought devastation countless times, reminding us that creation and destruction are two sides of the same coin. Consider the eruption of Mount Vesuvius in 79 AD, which buried the Roman cities of Pompeii and Herculaneum. Thousands died in an instant, their bodies preserved in ash, a frozen snapshot of human vulnerability. Or Krakatoa in 1883, whose explosion was heard thousands of miles away, creating tsunamis that killed over 36,000 people and plunging the world into years of global cooling. These were not isolated events. They were part of a pattern. When volcanoes erupt, they can unleash forces that reach far beyond their immediate surroundings, altering climate, disrupting economies, and shifting the trajectory of civilization. But some volcanoes go far beyond anything we can easily imagine. These are the supervolcanoes, capable of eruptions 1,000 times larger than anything in recorded history. The Yellowstone caldera in the United States is one of the most famous examples. Beneath its scenic geysers and hot springs lies a reservoir of magma so vast that, if it erupted on its largest scale, it could blanket much of North America in ash, collapse global agriculture, and trigger a volcanic winter lasting years. Humanity might survive such an event, but civilization as we know it would not. The last time Yellowstone erupted on a massive scale was about 640,000 years ago, long before modern humans walked the earth. We have no frame of reference for the chaos it would unleash today. And Yellowstone is not alone. The Toba supervolcano in Indonesia erupted around 74,000 years ago, in one of the most violent events in the last 2 million years. It may have triggered a global volcanic winter that lasted nearly a decade, reducing human populations to a fraction of their size and threatening our very survival as a species. The fact that we are here at all may mean that our ancestors endured one of the most extreme bottlenecks in history, clinging to life while the skies darkened and food became scarce. If true, then our species was forged in fire and ash, shaped by the wrath of volcanoes before civilization ever began. Even smaller eruptions can have outsized effects. In 1815, Mount Tambora in Indonesia erupted with such ferocity that it caused the year without a summer. Crops failed across Europe and North America, leading to famine, disease, and mass migration. The strange cold and dim skies inspired art and literature, even fueling the imagination of Mary Shelley as she wrote Frankenstein. A single eruption altered not just climate, but culture, leaving an imprint that stretched far beyond the ash cloud. Volcanoes do not just reshape land, they reshape human history. What makes volcanoes particularly terrifying is how unpredictable they are. Scientists monitor seismic activity, gas emissions, and ground deformation, but predicting the timing and scale of eruptions remains elusive. Some volcanoes give clear warning signs, rumbling and swelling for weeks before an eruption. Others strike with almost no notice. Mount Ontake in Japan erupted suddenly in 2014, killing dozens of hikers who had no idea danger was brewing. The unpredictability means that millions of people living near active volcanoes live with an invisible threat, one that can erupt at any time without mercy. The danger is not only in the explosion itself, but in the aftermath. Pyroclastic flows, fast-moving clouds of gas and ash, can incinerate everything in their path at speeds of hundreds of miles per hour. Lahars, or volcanic mud flows, can bury towns under rivers of debris. Ash clouds can collapse roofs, poison water supplies, and ground airplanes thousands of miles away. Even volcanic gases, invisible and silent, can kill. In 1986, Lake Nyos in Cameroon released a massive cloud of carbon dioxide from volcanic activity beneath the lake. The gas flowed silently into nearby villages, suffocating more than 1,700 people in their sleep. The eruption wasn't fiery, it was invisible, a reminder that volcanic danger takes many forms. Volcanoes also connect us to something larger, the restless engine inside Earth. They are the surface expression of mantle plumes and subduction zones, the places where tectonic plates dive into the planet or where hot material rises toward the crust. Each eruption is a window into Earth's interior, a glimpse of the forces that shaped continents, created islands, and fueled evolution. The Hawaiian Islands, for example, were born of volcanic activity and continue to grow as lava flows into the ocean. Iceland sits atop the mid-Atlantic ridge, where volcanic eruptions are slowly tearing the ocean floor apart, expanding the Atlantic Ocean inch by inch. Without volcanoes, Earth would be static, lifeless and cold. With them, it is alive, but dangerously so. Some scientists believe volcanoes even play a role in long-term climate regulation. By releasing carbon dioxide into the atmosphere, they help maintain a greenhouse effect that keeps Earth from freezing over completely. At the same time, massive eruptions can inject sulfur dioxide into the stratosphere, reflecting sunlight and cooling the planet. This delicate balance between warming and cooling, between life and death, is part of Earth's natural thermostat. But it is a thermostat that doesn't care about us. It shifts violently, often unpredictably, and we are left to cope with the consequences. And then there's the haunting question: how many volcanoes remain hidden beneath the oceans, their power unmeasured and unseen? Most volcanic activity on Earth happens not on land but under the sea, along mid-ocean ridges where plates diverge. These submarine volcanoes shape the seafloor, release gases, and sometimes build entire islands that rise suddenly from the waves. Yet we know almost nothing about them. The oceans hide their fury, and one day a massive undersea eruption could unleash tsunamis or trigger climatic shifts without warning. Volcanoes are not just natural features of the landscape, they are reminders that Earth is not a finished product. It is a planet still under construction, still reshaping itself through fire. They are monuments to creation and omens of destruction, symbols of both life's beginnings and its fragility. We stand on land that volcanoes built, we breathe air they released, we drink water they helped form, and yet we live in constant danger of their return. Perhaps the most chilling truth about volcanoes is that they are inevitable. They will erupt again and again. Long after we are gone, long after our cities are dust, they are timeless, patient, and unstoppable. And as much as we study them, monitor them, and try to predict them, we are powerless to control them. The fire below is always there, waiting. The ocean looks calm from the shore, an endless blue stretching beyond the horizon, sparkling under the sun. It lulls us into believing it is gentle, predictable, even comforting. But that calmness hides an unforgiving truth. The ocean is one of Earth's greatest forces, capable of destruction on a scale that dwarfs human power. For all our ships, submarines, satellites, and models, we understand only fragments of its full strength. And when it turns violent, no technology can truly stop it. The wrath of the ocean comes in many forms: tsunamis, hurricanes, storm surges, rogue waves, and each one is a reminder that the water which sustains life can also erase it in moments. Tsunamis are among the most feared ocean disasters, triggered by underwater earthquakes, volcanic eruptions, or landslides. They are not the towering Hollywood-style waves that crash dramatically on the shore. At first, they may look like nothing more than a rapidly receding tide, an odd phenomenon easily mistaken for curiosity rather than a warning. But then, within minutes, walls of water return with devastating speed and power, sweeping away everything in their path. In 2004, the Indian Ocean tsunami killed more than 30,000 people across 14 countries. Entire coastal towns were obliterated, families torn apart, and survivors left staring at landscapes that no longer resembled home. The most haunting detail: many people had no idea what was coming. They saw the ocean withdraw, revealing seabeds that had not been exposed for centuries, and instead of fleeing, they walked closer, unaware that doom was racing toward them at jetliner speeds. That tragedy revealed how fragile we are before the ocean's hidden fury. But tsunamis are not the only manifestation of the ocean's wrath. Hurricanes, typhoons, and cyclones, different names for the same monstrous storms, are fueled by warm ocean waters, transforming heat into rotating engines of destruction. When Hurricane Katrina struck the Gulf Coast in 2005, the storm surge it unleashed drowned neighborhoods, shattered levees, and displaced hundreds of thousands of people. More than a decade later, scars of that disaster remain. The ocean feeds these storms, and as climate change warms the seas, they grow stronger, wetter, and slower moving, lingering over regions with unrelenting rainfall and wind. Hurricanes are not just storms, they are sustained assaults combining the fury of wind, water, and waves into a single prolonged disaster. Storm surges, masses of water pushed onto land by these storms, are often more deadly than the winds themselves. In 1970, the Bola cyclone in what is now Bangladesh unleashed a storm surge that killed an estimated 300,000 to 500,000 people, making it one of the deadliest natural disasters in recorded history. Imagine the horror. Entire villages swept away in hours, farmlands turned to saltwater wastelands, and survivors left with nothing but loss. The ocean doesn't need to be subtle. It can erase civilizations with brute force, and history shows it has done so many times. Even on calm days, the ocean has surprises. Rogue waves, sometimes called freak waves, are sudden towering walls of water that appear without warning, often more than twice the height of surrounding waves. For centuries, sailors told tales of massive waves that came from nowhere, swallowing ships whole. Scientists dismissed these accounts as exaggeration or myth, until satellite data and modern measurements confirmed that rogue waves are real. Some reach 80 to 100 feet high, slamming with the power of small explosions. Unlike tsunamis, they are not tied to earthquakes or volcanoes. They emerge from chaotic interactions of wind and currents, making them nearly impossible to predict. Out in the open ocean, there is no defense. If a rogue wave appears, survival is little more than chance. The wrath of the ocean is not limited to the surface. Beneath the waves, landslides on the seafloor can displace vast amounts of water, generating tsunamis more powerful than those caused by earthquakes. These submarine landslides remain largely invisible until it is too late. The collapse of volcanoes into the ocean, too, can trigger waves that radiate outward with catastrophic effects. Scientists warn that if part of the volcanic island of La Palma in the Canary Islands were to collapse into the Atlantic, it could generate waves hundreds of feet high, reaching as far as North America's east coast. The sheer possibility of such an event shows that the ocean hides not just power but potential horrors yet unrealized. And what makes the ocean's wrath even more terrifying is its global reach. An earthquake in Chile can send a tsunami across the Pacific, striking Japan or Hawaii hours later. A volcanic eruption in Tonga in 2022 sent shockwaves through the ocean and atmosphere, felt across the entire planet. The ocean connects every coastline, every nation, every island. Its fury in one place can ripple into tragedies on the other side of the world. It is not confined to borders, it belongs to the planet, and when it lashes out, the entire planet feels it. But the ocean's wrath is not just about singular disasters. It is also about the slow, relentless encroachment of rising seas. Driven by melting ice sheets and thermal expansion from global warming, the ocean is creeping higher each year, swallowing coastlines inch by inch. For millions living in low-lying countries like Bangladesh, the Maldives, or island nations across the Pacific, this is not a distant threat, it is a present reality. Salt water contaminates drinking supplies, floods farmland, and displaces communities, forcing migrations that could reshape geopolitics in the decades to come. The ocean does not need a storm or an earthquake to show its power. It can simply rise, steadily, unstoppably, until entire regions are lost beneath the waves. And yet, despite all this danger, humanity has always been drawn to the ocean. We build cities on coastlines, rely on it for trade, food, and travel, and stand in awe at its beauty. That is the paradox. The very force that sustains us is also the one most capable of destroying us. The ocean provides, but it also takes. Its wrath is not personal. It is natural, an inevitable expression of energy moving through Earth's systems. We cannot control it. We cannot bargain with it. And when it comes, our only option is to endure. Perhaps the most unsettling part of the ocean's wrath is how little we truly know. Scientists estimate that more than 80% of the ocean remains unexplored. We do not fully understand its currents, its depths, or the complex interactions that give rise to catastrophic events. The ocean is still a mystery, and mysteries carry danger. Somewhere out there, in the deep trenches or along submarine ridges, forces are building, waiting for the moment when balance tips and the calm blue surface becomes chaos. In the end, the ocean is not an enemy, it is simply itself, vast, ancient, and indifferent. But when it unleashes its wrath, we are reminded of our place in the world, fragile creatures clinging to coastlines, daring to believe we can master what was never meant to be mastered. The ocean's fury is as old as Earth, and it will continue long after we are gone, reshaping shores, drowning cities, and reminding future life forms that water, as beautiful as it is, always carries the power to destroy. When people talk about disaster, they often mean hurricanes, earthquakes, or volcanic eruptions, events that are devastating but localized. Yet Earth has faced catastrophes so vast, they wiped out not just cities or regions, but entire species, reshaping the course of life itself. These are extinction events, moments when the planet pressed a brutal reset button, erasing dominant creatures and clearing the way for something new. For most of Earth's history, life has flourished only to be nearly annihilated, again and again. And what's chilling is that these events were not accidents. They were part of Earth's natural cycles. If they happened before, they can happen again. The most famous extinction is, of course, the one that ended the reign of the dinosaurs. Around 66 million years ago, a massive asteroid slammed into what is now the Yucatan Peninsula in Mexico, creating the Chicxulub crater. The impact released more energy than billions of nuclear bombs, igniting wildfires across continents, hurling debris into the sky and blocking sunlight for months. Temperatures plummeted, ecosystems collapsed, and 3/4 of all species vanished. The dinosaurs, which had dominated Earth for over 160 million years, were suddenly gone, making room for mammals to rise. Without that asteroid, humans might never have existed. It's unsettling to think that our very existence is the result of a cosmic accident. Life's path shifted not by design but by destruction. But the dinosaur extinction was just one of many. In fact, Earth has faced at least 5 major mass extinctions. The deadliest of all was the Permian-Triassic extinction, around 352 million years ago, often called the Great Dying. Triggered by massive volcanic eruptions in what is now Siberia, it unleashed floods of lava, spewed toxic gases, and triggered climate chaos. Ocean temperatures soared, oxygen levels plummeted, and nearly 90% of all species on the planet were wiped out. Imagine that, almost everything alive gone, leaving Earth nearly barren. It took millions of years for life to recover, and when it did, the stage was set for the rise of the dinosaurs. Other events followed: the late Devonian extinction, wiping out most marine life; the Triassic-Jurassic extinction, clearing the way for dinosaurs to flourish; and the Ordovician-Silurian extinction, one of the earliest, where dramatic shifts in climate caused ice sheets to form and then melt, devastating sea creatures. Each time, life was brought to the brink. Each time, Earth reset itself. Extinction events are not glitches in the system. They are part of the system. What's unnerving is that many of these extinctions were driven not only by asteroids but by Earth itself. Volcanism, climate change, shifting oceans, and atmospheric collapse have all played roles. In some ways, Earth is its own executioner, reshaping its biosphere with brutal efficiency. Volcanoes can pump carbon dioxide and methane into the air, triggering runaway greenhouse warming, or spew sulfur dioxide that cools the planet into deep freeze. Oceans can stagnate, turning toxic as oxygen disappears. The balance of life is delicate, and when Earth tips that balance, the fallout is catastrophic. And the unsettling question is this: are we living through the beginning of another extinction right now? Scientists call it the 6th extinction, and unlike the ones before, this one is being driven not by asteroids or volcanoes but by us. Species are disappearing at a rate far faster than normal background extinctions. Habitat destruction, climate change, pollution, and overexploitation are wiping out creatures across the globe. Amphibians, coral reefs, insects, life forms we take for granted are collapsing before our eyes. If trends continue, within centuries or less, the biodiversity of our planet could be gutted. We may be writing the next chapter in Earth's long history of extinction events, but this time we are both victim and perpetrator. Extinction events show us that survival is never guaranteed. For every species that thrives, countless others fall. 99% of all species that have ever lived are now gone. Think about that. Almost everything that ever existed on this planet has been erased. Humanity is not immune. We have technology, cities, and global networks, but in the face of planetary-scale disasters, those tools may not save us. An asteroid impact, a supervolcano eruption, or runaway climate change could strip us down to nothing, just as it did with the creatures that came before. Our arrogance makes us believe we are untouchable, but the fossil record tells a different story. The terrifying reality of extinction events is their suddenness. For millions of years, Species can dominate, thriving in stable ecosystems, until in an instant, the balance shifts. Dinosaurs had no reason to believe their reign was ending, just as trilobites did not know their time was up. And perhaps we too live in an age where the signs are around us, but we choose not to see them. The climate is warming, seas are rising, species are vanishing, and still we carry on as though the system will hold. But history suggests otherwise. The system always and yet, there is a strange beauty in this cycle. Extinctions, as devastating as they are, also open doors. When the dinosaurs fell, mammals rose. When the great dying ended, new life forms evolved, more resilient and adaptable. Extinction clears the slate, allowing Earth to reinvent itself. This is why scientists call them creative destructions. They are brutal, but they are also the reason life is as diverse as it is today. Without them, evolution might have stagnated, locked into patterns too stable to allow change. Extinction ensures renewal, even if the price is unfathomable. Still, that idea offers little comfort when you imagine what it would mean for us. Picture a future where humanity falls to famine, disease, or climate collapse. Cities crumble, technology rusts, and the species that once built rockets to the moon disappears like the trilobites and dinosaurs before it. And then slowly, something new emerges. Perhaps intelligent birds, mammals, or entirely new forms of life rise in our place. They might one day dig up our fossils, study our ruins, and wonder what ended us. For them, we would be a lesson, just as we study the bones of dinosaurs for clues about survival and failure. Extinction events are Earth's harshest reminder that it does not belong to us. We belong to it. The planet is ancient, resilient, and constantly in flux. We are only temporary guests. Our time here, no matter how powerful we think we are, is finite. Extinction is not just a possibility, it is an eventuality. The only question is whether it will come from a cosmic rock, a supervolcano, our own self-destruction, or something we have yet to imagine. And maybe the scariest truth of all is this: Earth does not care. Life will return after we are gone, just as it always has. The planet has endured 5 mass extinctions, and it will endure a 6th, a 7th, and countless more. The reset button will be pressed again, and when it is, we will be nothing but another layer in the fossil record, a footnote in the story of life. That's the power of extinction events. They erase not just species but entire chapters of history, leaving only silence, ash, and the opportunity for something new to rise. Humanity stands at a crossroads unlike any other species before us. Unlike the dinosaurs who had no choice when the asteroid struck, or the trilobites that slowly vanished as oceans changed, we are aware of our own fragility. We can see the dangers on the horizon: climate change, nuclear war, artificial intelligence, pandemics, ecological collapse. And yet, knowing all this, we continue to gamble with the future as though the odds do not apply to us. It is this awareness that makes our story both remarkable and terrifying. We are the first species in Earth's history capable of foreseeing its own potential extinction, and yet we behave as though survival is guaranteed. Our gamble begins with the environment. In just a few centuries, we have altered the climate in ways that normally take millions of years. Carbon dioxide levels are higher than at any point in human history. Seas are rising, and ecosystems are unraveling. We know this, and still, we burn fossil fuels, clear rainforests, and pump toxins into the air and water. We are betting that our technology will save us before the damage becomes irreversible. But history shows that nature does not negotiate. The climate system is not a machine that can be paused or rewound. It is a vast, interconnected web. Once it tips past a threshold, there is no turning back. Yet our gamble continues, as though the dice will always land in our favor. We gamble too with technology itself. The same brilliance that put a man on the moon and mapped the human genome has also created weapons that could annihilate us in minutes. Nuclear arsenals sit ready. Thousands of warheads capable of plunging the world into a nuclear winter that would starve billions. The Cold War showed how close we came to pressing that button, how fragile peace really is when destruction hangs by a thread. Even today, with shifting alliances and rising tensions, the danger remains. Our gamble is that leaders will never miscalculate, that no accident, mistake, or act of desperation will trigger the unthinkable. But can we truly trust ourselves with such power forever? Beyond weapons, artificial intelligence presents another gamble. It is a tool of immense potential, promising to cure diseases, solve global problems, and transform economies. But it also carries risks we barely understand. A system more intelligent than us could act in ways we cannot predict or control. It could reshape society, strip us of autonomy, or even view us as irrelevant. Some experts warn that AI could become an existential threat, yet we rush forward, competing to make it smarter, faster, more powerful. The gamble here is that we will manage to control it, that we will guide it responsibly. But history suggests we rarely restrain ourselves when new technology dangles power before us. We press forward, hoping consequences will wait. Then there is biology, the double-edged sword of genetic engineering and biotechnology. With the ability to edit DNA, we can eliminate diseases, extend life, and enhance human potential. But we also risk creating superbugs, weaponized pathogens, or mistakes that spiral out of control. Pandemics have shown how vulnerable we are to tiny organisms. The Black Death in the 14th century killed millions, reshaping Europe. The 1918 influenza swept across the globe, infecting a third of humanity. And most recently, COVID-19 shut down the world, collapsing economies and killing millions, despite our advanced medicine. Imagine a future pandemic, whether natural or engineered, with far greater lethality. We gamble that we will always find a cure in time, that science will outrun the threat. But viruses do not wait for human convenience. Even space carries risks. Asteroids and comets still cross Earth's orbit, just as they did 66 million years ago. NASA and other agencies scan the skies, but countless objects remain undetected. A single strike from a large asteroid could trigger global fires, tsunamis, and years of darkness, ending modern civilization overnight. Our gamble is that such an impact won't happen in our lifetime, or that if it does, we will have the technology to stop it. Yet right now, our defenses are limited. Early warning systems, small-scale deflection tests. The cosmos is vast, and our preparations are tiny. Once again, the gamble continues. But the most dangerous gamble of all may be with ourselves. Our ability to cooperate, to act collectively, to place long-term survival above short-term gain. History is filled with wars, greed, and power struggles, even in times of abundance. When resources grow scarce, when climate pressures mount, when populations clash, will we rise together or turn against each other? The truth is, we don't know. Our gamble is that human nature will bend toward cooperation when it matters most. Yet the signs are not comforting. We bicker, divide, and chase profit, even as existential threats loom. The biggest obstacle to our survival may not be nature or technology, but our own inability to act as one species on one planet. And yet for all these dangers, humanity's gamble is also rooted in hope. We gamble because we believe in ourselves. We have survived ice ages, plagues, and world wars. We have turned deserts into farms, tamed rivers, and reached for the stars. Our resilience is real. Our intelligence is real. We gamble because we think we can beat the odds, bend the rules, or rewrite the story, and perhaps against all logic, we might. But the stakes have never been higher. This is not a simple wager on crops or battles. It is a wager on existence itself. If extinction is Earth's reset button, then we now hold our finger over it too. The difference is that we can choose whether or not to press it. Every decision, how we use resources, how we handle technology, how we treat the planet, adds weight to the scale. We may be the first species in history with the ability to anticipate its end and take steps to avoid it. That gives us power, but also responsibility. Yet responsibility is easy to ignore when profit and power whisper louder. That is the essence of humanity's gamble. We risk everything because we believe tomorrow will always come. But what if tomorrow doesn't? What if the dice roll against us? Unlike other creatures, we will not be able to say we didn't know. The dinosaurs had no idea an asteroid was coming. The trilobites didn't see the oceans changing until it was too late, but we see the signs. Melting ice, burning forests, mass extinctions, rising seas. We know the risks of nuclear weapons, of pandemics, of unchecked technology. If we fall, it will not be out of ignorance, but arrogance. That is the true danger of our gamble. Not that we don't know, but that we do and still carry on. In the end, humanity's gamble with the future is both inspiring and tragic. Inspiring because it shows our boldness, our refusal to bow to fear, our belief in progress. Tragic because it shows our blindness, our recklessness, our willingness to risk it all for comfort and power. We stand on a knife's edge, aware of the abyss below, yet we dance on it anyway. The dice are rolling, the future waits, and the question that hangs in the balance is this: will humanity's gamble pay off? Or will we become just another layer in Earth's fossil record? Another reminder that life never holds the winning hand forever. Humanity prides itself on control. We build dams to tame rivers, cities to dominate landscapes, satellites to map the globe, and machines to extend our reach into space. Everywhere we look, there are signs of our attempt to bend nature to our will. Skyscrapers pierce the clouds, airplanes cut through the skies, and our networks connect billions in an instant. We tell ourselves that we are masters of this planet, that nothing lies beyond our ingenuity. But beneath this confidence lies a dangerous truth. Control is an illusion. The Earth is not tamed, the systems we rely on are fragile, and the forces that govern our world are far greater than anything we can build. Our belief in control is comforting, but it is also a mask that hides how little we truly command. Consider the weather. With satellites, supercomputers, and endless data, we can forecast storms with impressive accuracy. Yet we cannot stop them. Hurricanes still flatten cities, droughts still wither crops, and heat waves still kill thousands. We build walls against floods, but the waters rise higher. We seed clouds, hoping to coax rain, but we cannot rewrite the sky. Every year, natural disasters cost billions and take lives, reminding us that prediction is not power. We know what's coming, but we cannot prevent it. Our illusion of control makes us think awareness equals mastery. But when nature strikes, it tears through our defenses like paper. Earthquakes prove this even more brutally. They strike without warning, shattering the ground, crumbling buildings, and burying lives in seconds. No amount of technology can stop tectonic plates from moving. We can design stronger structures, build warning systems, and study fault lines, but we cannot prevent the ground from tearing itself apart. In moments like these, our control vanishes, replaced by the realization that we are passengers on a restless planet. We sit atop shifting slabs of rock, yet we build as though the Earth is permanent and obedient. That is the arrogance of our illusion. Volcanoes tell a similar story. We admire their beauty, marvel at geysers and hot springs, and even profit from fertile soils born of eruptions. But when the fire below decides to rise, we are powerless. Ash clouds can ground flights across continents. Pyroclastic flows can erase towns in minutes. Supervolcanoes, like Yellowstone, hold enough energy to plunge the world into years of volcanic winter. We monitor them, yes, but monitoring is not mastery. They erupt on their own timetable, not ours. We like to believe we have tamed fire, lighting our cities with electricity, harnessing nuclear power, but the fire inside the Earth is beyond us. It always has been. And then there is the ocean. We cross it with cargo ships, drill it for oil, and cast nets to pull life from its depth. But the ocean remains a realm we barely understand. Storm surges overrun our walls, tsunamis sweep away entire coastlines, and rogue waves swallow ships whole. Even as satellites scan the surface, more than 80% of the ocean floor remains unexplored. There may be mountains taller than Everest down there, trenches deeper than imagination, forces building that could reshape coasts in hours, and we would never see them coming. Our ports, our cities, our economies all rest on the illusion that the ocean is manageable. But when it decides to show its strength, we remember that it is ancient, vast, and indifferent. The greatest illusion of control comes not from nature, though, but from ourselves. We think we rule our societies, but our systems are fragile webs, easily torn. Economies collapse with a stock market crash, supply chains falter with a single blockage, and cities grind to a halt from a virus too small to see. The COVID-19 pandemic was a brutal reminder. In weeks, flights stopped, shelves emptied, and entire nations shut down. Billions lived under restrictions not because we lacked intelligence, but because even our vast infrastructure could not withstand a microscopic threat. Control dissolved into chaos, and the illusion cracked. Technology deepens this illusion. Every new invention convinces us we are stronger. Smartphones make us feel connected. Satellites give us godlike vision. Artificial intelligence promises solutions beyond human capacity. But each innovation brings new vulnerabilities. Power grids can be hacked, AI can act unpredictably, and digital networks can collapse in an instant. The more control we think we gain, the more fragile we become. It is a paradox. Our dependence on technology creates the illusion of mastery, but also increases our exposure to failure. The illusion is so complete that many cannot imagine life without these systems. Yet they rest on fragile foundations, wires, code, servers that could fail tomorrow. We even try to control time. We measure it, schedule it, optimize it, squeezing productivity from every second. But time is indifferent. Clocks tick on whether we notice or not. Aging happens no matter how much we resist. We invent medicines, chase immortality, edit DNA, but the passage of time is relentless. Civilizations rise and fall, and every empire once convinced of its permanence eventually dissolves into ruins. Rome believed it would last forever, so did countless kingdoms and dynasties before and after. History shows that no matter how much control we think we wield, time humbles all. The illusion of control is dangerous because it breeds complacency. Believing we are safe, we take greater risks. We build cities in flood zones, ignore climate warnings, and stockpile weapons capable of ending the world. We live as though the systems we created are unshakable, forgetting how fragile they are. Our arrogance blinds us to the truth. We are not in charge, not really. At best, we adapt to Earth's moods. At worst, we pay the price for pretending we are above them. And yet, perhaps the most unsettling aspect of this illusion is how much we need it. Without it, fear would paralyze us. If we truly grasped how fragile our existence is, how easily an asteroid, a supervolcano, or even our own mistakes could erase us, we might collapse into despair. The illusion of control allows us to live, to build, to dream. It is a lie, but it is a useful one. We cling to it because acknowledging the truth that we are fragile, temporary, and small would overwhelm us. Control may be an illusion, but it is also a survival mechanism for the mind. Still, illusions cannot hold forever. Cracks always appear. Every disaster, every collapse, every unexpected crisis reminds us of reality. The Earth is not ours to control, technology is not infallible, and societies are not unbreakable. We are temporary, living in a narrow window of stability that could close without warning. The only real power we have is not to command Earth, but to adapt to it. Control is a myth. Adaptation is survival, and if we confuse the two, if we continue believing the mask is reality, then the moment the mask shatters we may find ourselves unprepared for what lies beneath. In the end, the illusion of control is the greatest gamble humanity has ever played. We act as though mastery is permanent, when in truth it is borrowed. The planet allows us moments of calm, periods of growth, and windows of prosperity, but it owes us nothing. We are tenants, not owners, and one day the lease will expire. The illusion soothes us, but it also blinds us. And when Earth decides to remind us who is truly in charge, the fall from that illusion will be brutal. The question is not whether the illusion will shatter. It always does. The question is whether we will recognize the truth in time to survive the reality waiting behind it. The story of Earth is not one of stability, but of constant upheaval. From the violent birth of continents to the shattering blows of extinction events, from the wrath of the ocean to the fire of volcanoes, this planet has never been still. We often think of Earth as our home, a safe and familiar place designed for us. But the truth is harsher. Earth is not here for us. It existed long before we arrived, and it will continue long after we are gone. Every mountain range, every ocean trench, every shifting fault line whispers the same truth. This is a restless world, and we are only temporary guests upon its surface. Throughout history, life has been shaped not by comfort, but by catastrophe. Mass extinctions cleared the slate, earthquakes toppled civilizations, and eruptions darkened skies for years. Yet each time life endured, adapted, and began again. Humanity's story is no different. We rose not because Earth made space for us, but because chaos cleared the way. The asteroid that ended the dinosaurs was also the spark that allowed mammals and eventually us to flourish. But that gift came with a warning. The same forces that cleared the stage once can do it again. Extinction is not a relic of the past. It is a cycle, and it will return. And now, humanity finds itself in a unique position. For the first time, a species on this planet is aware of the dangers it faces. We know about asteroids, volcanoes, climate change, and the fragility of ecosystems. We can see the signs written across the planet's surface and in its atmosphere, yet knowing does not guarantee survival. Knowledge without action is nothing. The gamble we continue to play, burning through resources, escalating risks with technology, and clinging to the illusion of control may be the very thing that ensures our downfall. Earth has always reset itself, and if we push too far, we may trigger the next reset ourselves. But within this unsettling truth lies something remarkable: the power to choose. Unlike the trilobites or the dinosaurs, we can prepare, adapt, and even protect ourselves from some threats. We can track asteroids, design early warning systems, and slow the pace of climate change. We can decide to use technology wisely rather than recklessly. We can cooperate as a species rather than divide into factions that fight over scraps while the planet burns. The question is whether we will. The window is narrow, the odds uncertain, but the possibility exists. That possibility is humanity's greatest chance, and its greatest responsibility. In the end, Earth does not care. It will keep shifting, erupting, and renewing itself long after we are gone. Life will return, whether in the form of insects, birds, or something entirely new. Our presence or absence will not matter to the planet. The real question is not whether Earth will survive. It will. The question is whether we will survive with it, or whether we will simply become another layer in the fossil record, another vanished species erased by forces far larger than ourselves. So as we look at the ground beneath our feet, the oceans that stretch to the horizon, and the skies above that hold both storms and cosmic debris, we are reminded of one thing: survival is not guaranteed. Our place here is fragile, temporary,